Hello students, my name is Shashank Shekhar. So let us continue with the chapter of some basic concepts of chemistry. So today we are on the Dalton's atomic theory. So let us start our today's class. So first of all, the first atomic theory that was given by Dalton, it says that it was the most starting point for the tiny atomic theory. Before that, no atomic theory was given. So there are some main postulates of this atomic theory that should be mentioned. Okay. So the first thing is that matter is composed of indivisible particle. Indivisible particle means the particle which cannot be fragmented or broken into simpler particle. So they are composed of indivisible particle, which he called it as atomio, which means indivisible or which cannot be fragmented. And he said some postulates. So first postulate was obviously that the matter was composed of indivisible particle. Second one was all atoms of a given element have identical properties including identical mass. So what does this mean? So if you take iron compound and take one atom from a side, say from iron atom from one iron element, and you take another iron atom, say from a concrete system, okay, or from any table or any body, then you will see that each iron atom you are picking have the identical properties, whether you talk about chemical properties or whether you talk about identical, they have identical masses and all. Whereas these masses are unique to that element only. If you take another atom, okay, so that will always have a different mass. Now compounds are formed. How are compound formed? When these atoms of different elements combine in a fixed ratio. So they should combine a fixed ratio. So example, if you take the example of ammonia, then the ratio is 1:3, where 1 is for nitrogen and 3 is for hydrogen. Its formula is NH3. So one comes from nitrogen and 3 comes from hydrogen. So 1:3. Now he defined chemical reactions as the rearrangement of the atoms, and in this process they are neither destroyed nor created. Clear? So this was the first atomic theory that was given by Dalton. Now what was the drawback of Dalton atomic theory? He cannot explain the laws of chemical combination. Okay. Also, he could not explain the law of gaseous volumes, and he cannot provide the reason for combining of atoms, which was answered later by other scientists. So he said that the atoms will combine, but he did not give any validation for that. Now, after that, atomic mass was defined. So today we have sophisticated techniques, example mass spectrometry, for determining the atomic mass more accurately. So in the 19th century, scientists could determine the mass of an atom only in relation to some a standard. So for in that process, hydrogen was first taken and it was used as the standard. Then it was transferred out to oxygen. But now in the present system, the carbon 12 atom is considered as the standard for determining the relative atomic mass. And the isotope of carbon that is used is the 12C carbon. So in this system, the 12C carbon is assigned a mass of exactly 12 atomic mass units. Now this AMU was later on replaced with U, that is the unified mass, and this is the currently used unit. And the mass of all other atoms are given in relative relation to that standard. Now one atomic mass unit is defined exactly as the mass that is present in 1/12 of the mass of a carbon 12 atom. So if you calculate the mass of one carbon 12 atom and you divide it by 12, that would be equal to one atomic mass unit. So as I said earlier, first hydrogen was taken. So it was seen that the mass of one hydrogen atom was this much. Okay. Then one AMU is this one. We know this. So if we divide both of this, we will get your 1.0880. So this is nothing but 1/12 of the mass of a carbon 12. So we have divided this mass of hydrogen with this to get the relative mass. You can see that how we are taking the relative mass. So what we have done, we have taken 1/12 of the mass of a carbon 12 atom and then divided, we have put it in denominator, and the numerator we have taken the mass of the hydrogen atom, and with relation to that we have calculated its mass as 1.0078 or 1.008. This is not 0 here. Similarly, We have calculated the mass of oxygen atom as 15.995, which is approximated to 16 often, but now it is used as U. Okay, so this is abbreviated as U rather than AMU. We have U, that is called unified mass. So hydrogen will have 1.008 U, atomic mass of hydrogen. So when we use atomic masses of elements in calculation, we actually use average atomic mass. This is very important point. Okay, so what is the meaning of this? See, so in nature, when we talk about one element, an element can exist in multiple types. So most of the elements have isotopes of that. So isotopes are what? Which have the same atomic number but different atomic mass. Okay. Now, if you want to say that this is the atomic mass of, say, carbon atom, by this, what do you mean? You're talking about 12 carbon atom, or you're talking about 13 carbon atom, or are you talking about 14 carbon atom? So to remove that confusion, what we have done, we have taken an average of that. How we have taken the average of that? See, the formula is very simple. First, let us write the name of each isotope. So let us take the example of carbon. It has three isotopes, 12C, 13C, and 14C. Then we have taken the relative abundance, means say it is a type of percentage, you can say relative abundance percentage, means the what percentage of C12 is present among the total carbon, what percentage of C13 is present, and what percentage of C14 is present. Okay, and we have gathered their atomic mass. Is this clear? So we have three isotopes. We have taken their relative abundance, that is the percentage, its total contribution, and their atomic mass of each of these. Further, what we have done, we have taken the relative fraction rather than the percentage. We have divided that 98 by 100 and we got this, and we multiplied it with their atomic mass. Similarly, we have done this the same for the second isotope, multiplied by the atomic mass, and for the third isotope, multiplied by the atomic mass. Then we added all of this to get this. So you can summarize this formula of average atomic mass as average atomic mass can be summarized as, how it can be summarized? Fractional relative abundance. So I am representing fractional relative abundance by, say, X. So this is the fractional relative abundance of ith isotope multiplied by the atomic mass of the same ith isotope, and will sum over all i's that we have, means all isotopes that are available. Now, whenever we talk about atomic mass, we always talk about this average atomic mass, although we do not pronounce it frequently, but by atomic mass, we mean that average atomic mass, so that contribution from each isotope can be taken here. You can see that each isotope contribution has been taken here. Clear? Now, in the periodic table of element, the atomic mass mentioned are different for different element, actually represent their average atomic mass. So the atomic mass that you see on the periodic table, that is being mentioned along with the symbol, that is nothing but your average atomic mass. Clear? Next is molecular mass. What is molecular mass? So it is very clear. Molecular mass is nothing but your mass, atomic mass of your uh, individual atoms added according to their stoichiometry, and the overall mass sum is called as molecular mass. Or you can define it in another way, that is the mass of a molecule relative to 1/12 of the mass of a carbon 12 atom. So you can define it in the both ways. Now it is obtained by multiplying. How it is obtained? It is obtained by multiplying the atomic mass each element by the number of atoms that is present in one molecule and adding them together. For example, molecular mass of methane would be how it will be calculated, which contain one carbon and four hydrogen. So let us see. So we know the formula of methane, it is CH4. So there is one carbon. So one carbon has atomic mass of 12.011 unified mass, that is U, plus 4 hydrogen atoms. So 4 multiplied by 1.008 U. So we will add both of this to get the molecular mass. So this is the molecular mass. Similarly, if we have H2O, we can do the same thing. What we will do, we'll take the molecular mass of, atomic mass of hydrogen, multiply it by 2, and again we will multiply the atomic mass of oxygen by 1, because there is only one oxygen present, and we will add it to get this 18.02. We can take similar examples. Say we have ammonia. We have ammonia. How we'll calculate it? What is the atomic mass of nitrogen? It is 14. 14, okay. What is the atomic mass of hydrogen? So I'm not taking the exact value, I'm taking the approximate value. I'm not taking the values after the decimal. Atomic mass of hydrogen. So it would be 1 gram. So how you will calculate the molecular mass? Molecular mass. So it will be nothing but nitrogen has one count. So 14 multiplied by 1. Hydrogen has 3 counts. So 3 multiplied by 1. That would bring us to 14 plus 3. That is equals to 17 gram per mole. So we are calculating the molecular mass, right? So we'll write per mole. Again, we can have another example. Say we can have CO2. So it has carbon. So atomic mass of carbon is how much? It is 12. And atomic mass of oxygen is, we have seen it right now, it is 16. So molecular mass would be 12 multiplied by 1 plus 16 multiplied by 2. That would bring us to 32 plus 12 or 44 gram per mole. So you can try more examples by yourself. Now there is one more terms that come often. So we will study it in the next class, that is molar mass. Okay, what is molar mass? What is molar mass? So molar mass is nothing. It is molecular mass expressed as gram. Okay, we can call gram per mole as U also. Okay, gram per mole as U also. Yeah. So where are we? So you will study more about this molar mass, but for now, just I'm giving you a way to calculate the molar mass. So it is nothing but molecular mass that is expressed in grams. So if I talk about the molar mass of say ammonia, if we talk about the molar mass of ammonia, molar mass of ammonia, that would be 17 gram. Okay. Similarly, the similarly the molar mass of CO2 would be 44 gram. Clear? Next is formula mass. What is formula mass? So far we have seen molecular mass. So molecular mass was defined for molecule. This formula mass is defined for ionic molecules since ionic compounds, because ionic compounds do not form molecules. They form a closed 3D structure. So for that we have used the term formula. So this is termed as one formula unit. Okay, means if you calculate the molar mass of a ionic compound, then that unit will be called as formula unit and its mass will be termed as formula mass. But the way of calculation is same. We do not have any next idea to do so. So if you want to calculate the formula mass for sodium chloride, say, how I will calculate? So very simple. Mass of sodium plus mass of chlorine, that would give us 58.5 U. It may be noted in the sodium chloride. If I talk about the structure that is being shown here, so one sodium plus ion is surrounded by 6 Cl minus. That is the coordination number of sodium plus. We will talk about it in the solid state. So such a formula is used to calculate the formula mass instead of molecular mass in case of solid state. Okay. One more terminology I want to add here, that is termed as vapor density. So vapor density is generally used for gaseous or can use it for anyone. So vapor density formula is Nothing but whatever be the molecular mass, you have to divide the molecular mass by 2. So we have seen that carbon dioxide, means the molecular mass or the molar mass of carbon dioxide, was 44 gram. So what would be its vapor density? It would be 44 by 2. Clear? So this you should remember. Similarly, if you want to calculate the vapor density of say H2O, that would bring us to 18 by 2. Or say vapor density of nitrogen. So we know that nitrogen has a mass of 14 into 2 divided by 2, that is 14. Or say ammonia, vapor density of ammonia. So ammonia was having a mass of 17, that is 17 by 2, or 2 8 is 16, 8.5. So this vapor density is nothing but this is the mass of a say gas relative to a hydrogen molecule H2, and H2 has a mass of 2, so we divide by 2. So that's it. So if I write the actual definition, so vapor density is the mass of a species relative to the mass of hydrogen. So this was for today's class. Thank you.